This is assignment 4.5 part 2. I'm just going to be carrying on with where I left off. Firstly, I'm going to be starting about talking to you about outliers. Outliers relate to any points that are different from the majority of the data set. Outliers can affect data analysis. For example, it can impact on the mean, which can therefore impact on the interpretation about the mean. For example, when you look at the data on the screen, you can see that all of the dots are in like a collected in a nice little line, and it shows a positive correlation. However, there's one little dot which is 6030, which is just an outlier, and that will significantly affect the mean because it's just an outlier from all of the data and it's not in the trend of the graph. Another effect that the outlier could have upon the sample of the population, it could be negatively affected. Outliers can be visually seen in a raw data or graph. However, a calculation is required. First, you have to work out the interquartile range, which is the difference between the upper and the lower quartile. The upper quartile is the medium of the upper half of the data set, and the interquartile is the medium of the quartile of the data set. Once you have the interquartile range, you want to times it by 2. I'm now going to be talking to you about how to get rid of outliers. You can get rid of outliers by methods such as trimming and wind scissoring. Trimming is when you remove all of the outliers and normalize the data set. You are simply getting rid of all of the data set that is not meant to be there. However, this subsequently decreases the sample size, and this is very important in quantitative data analysis, as small sets of data loses all power and credibility due to limited amount of research, so cannot be trusted by other researchers. Alternatively, you can use wind scissoring, which is shown on the screen. This can be used to transform the outliers to the closest / nearest non-outlier. This method maintains the sample size and will not lose credibility for other researchers, so therefore it also can be trusted. In this instance, 2 has been turned into 10 and 22 has been turned into 14. The next part of quantitative data analysis is descriptive statistics. The data presentation stage provides the graphs required for the researchers to begin to show a relationship that are formed within the data. It is vital that graphs created show the data in the most effective and easily understandable forms. This is done by descriptive statistics. These are used to effectively show the relationship and the potential patterns that are included in your data. There are 2 types of central tendency and dispersion. Within these types of descriptive statistics, there are a number of different techniques that are used to describe the dynamic that may have begun to form in your data. The difference between central tendency and dispersion is the fact that central tendency is a single value that is used to represent the whole of your data, whereas dispersion shows the distribution and spread of the data within a single value. Firstly, examining the central tendency and the different forms of descriptive statistics that fall under this. There are 3 different types, and these are mean, median, and mode. First, let's start with the mean. Beginning with the mean. The mean shows the average of the data. The mean of the set of data can be found using the following equation, which is shown on the screen. This is the sum of the population mean, and for the sample mean, the equation is also shown on screen. The mean is an effective descriptive statistic to use, as it can be used on both continuous and discrete data, as it includes every value in your data in the equation and does not neglect any values. The mean is best suited to continuous data. Despite the benefits of including every value, it does also mean that potentially the mean could get affected by outliers. The effect that this could have on your data is it has the potential to make your data skewed. This means that the mean out of all 3 types of central tendency is the least robust and most likely to be manipulated by outliers. There are also a couple of additional problems with using a mean. The first of these is that sometimes the value you collected doesn't make sense. The final possible limitation to the mean is that ordinal and nominal data are unable to be used when trying to work out the mean. The example on screen shows how you work out the mean. What I have done is I have added up all of the values, and then I've divided them with the amount of values which is there, which is 10, and the answer that I've got is 28.4, and that is the mean of the data set. The next type of central tendency figure is the mode. This is typically the most common value within the data set, and the data that can have one or more mode if there are two or more values and the same amount of value. If within a data set all the values are the same or the values are all different, then it could be possible that the data set has no mode. It's most likely that there will not be a mode in continuous data. The mode does have some advantages over the other two values. The fact that it can be used in most frequency graphs as it can be used in nominal or categorical data. Despite the benefits of the mode, there is a main problem with using the mode to represent your data, and this is the fact that the mode often does not represent the rest of the data. The final type of central tendency is the median. This can be calculated in two different ways depending on whether your data is odd or even. If the data is odd, then you can simply remove an equal number of scores from each side until you are left with the middle number. Secondly, the data could be even. If this is the case, then you have to take an even number of the scores from each side of the data until you are left with the middle two values. You then work out the middle value of these two until you get to the median. The median has a number of advantages when trying to represent your data. The first of these being the fact that the data is less affected by outliers, which mean the median represents the central value better than the value is not skewed by outliers. There are also limitations despite the benefits. These include the fact that if you are trying to work out the median manually, then this can be a fairly slow process. Finally, the median is not very effective if the data set is small. Next, I'm going to be explaining to you about the range and dispersion. The dispersion refers to how the variation within the data set you have, and this can give you the information as to how scattered your data may be or potentially how dense it is. The three types of dispersion that the researcher can use is range, interquartile range, and standard deviation. Firstly, I'm going to be discussing with you about the range. This is the difference between the smallest and the largest value. The range has a major issue because of the fact that the range is affected greatly by any potential outliers that your data may contain. As your data might have a fairly small median, but then that could be completely changed by an outlier, therefore making the range very unrepresentative of the data. Despite the fact that the data can be massively affected by outliers, if there are no outliers in your data, then the range can be best used on symmetrical data. And this can be easy to work out and is a fairly simple equation. The range can be most effectively used in orderal data. Overall, the range has a major issue as it does not represent all of the data, just the extreme ends, which means the value connected does not show the shape of the data. With my example on the screen, for a statistic sprint times over 20 meters, the highest value that is in the table is 5.8 and the lowest value is 4.8. So I've literally just taken the highest value and the smallest value and subtracted them. So for within this example, the range would be 1. The next type of dispersion I'm going to be explaining is the interquartile range. The interquartile range varies from just the standard range as it only looks at the middle 50% of your data. Working out the upper quartile of 75% and the lower quartile of 25% of your data in order to gain a representation of both the lower sections and the higher section of your data. There are 3 different equations that can be used to help the researcher work out the lower quartile, median and upper quartile. Firstly, looking at the lower quartile, and this is worked out by using the following equation which is shown on screen. The median is then worked out by the equation which is shown on screen, which is n plus 1 divided by 2. And finally, the upper quartile is worked out by 3 times brackets n plus 1 divided by 4. Similar to the range, ordinal data works very effectively when using the interquartile. However, the interquartile range, by only working out the 50%, it means that the outliers are not affecting the factor for the interquartile range. This means that the interquartile range can represent the data collected more effectively than the range. However, the interquartile range does reject 50% of the data collected, which could then mean the final interquartile range is not representative of some of your data. The interquartile range is compared to the range. It's more difficult to work out and can be slightly harder to understand. The final type of descriptive statistics is standard deviation, which relates to the mean as it provides a figure that shows how far the number varies from the mean. In order to work out the standard deviation of the data, you need to use the following equation, which is shown on screen to the right, far right. When working out the standard deviation of your data, the visual representation can give a lot of information about the standard deviation on your graph. The first detail to notice is how high and wide your standard deviation marks are. As if they are wide, then this means that there is a large variation from the mean and your data or large standard deviation. A narrower standard deviation curve equates to a smaller standard deviation, Therefore, a smaller standard deviation means that the value is going to be lower than the number as it is closest to zero. A researcher will want to see if a smaller standard deviation in their data because the mean that they have worked out will be a better representation of the data, and it can be possible to not have a standard deviation if there is a set of values that are all the same. The standard deviation is incredibly helpful as it can help to put some real meaning to your data, as standard deviation are an effective descriptive statistic at doing this. It also is very helpful as it uses the same type of measurements as your data.